National Electrical Code Section 315.6 and specifically Table 310.16 does not provide ampacity ratings for 120/208 volts three-phase conductors because these types of conductors are not typically utilized in the United States for feeder installations. It is important to understand why this is the case. Firstly, 120/208 volts three-phase systems typically require a neutral conductor. Table 310.16 does not explicitly account for the presence of a neutral conductor carrying significant current. In a three-phase system, the neutral conductor can carry a substantial amount of current, especially when the load is unbalanced. When a load is considered unbalanced, it means that the current draw on each of the three phases is not equal. This imbalance can result in current flowing back through the neutral conductor. Secondly, applying Table 310.16 to 120/208 volts three-phase conductors would necessitate significant derating due to the neutral conductor. Derating is the process of reducing the allowable ampacity of a conductor to account for various factors such as ambient temperature, the number of conductors in a raceway or cable, and the presence of harmonic current. The presence of a neutral conductor carrying substantial current would require a significant derating factor, which would subsequently reduce the overall ampacity of the feeder. This derating is necessary because the neutral conductor generates heat, which can affect the temperature rating and performance of the other conductors in the same raceway or cable. Thirdly, the code does not provide specific ampacity ratings for 120/208 volts three-phase conductors in Table 310.16 because the ampacity values listed in the table are based on specific assumptions about the conductor type, insulation, temperature rating, and installation conditions. These assumptions may not be applicable to 120/208 volts three-phase systems with a neutral conductor. The ampacity of a conductor is the maximum amount of current that it can safely carry without exceeding its temperature rating. The temperature rating of a conductor's insulation is the maximum temperature that the insulation can withstand without degrading or failing. The installation conditions, such as the ambient temperature and the presence of other conductors, can also affect the ampacity of a conductor. It's important to consider the design and application of 120/208 volts three-phase systems, as they typically serve multi-wire branch circuits, where the neutral conductor is essential for carrying unbalanced loads and providing a return path for current. In this context, the ampacity of the conductors is usually determined based on the specific requirements of the branch circuits and the applicable derating factors. The absence of specific ampacity ratings for 120/208 volts three-phase conductors in Table 310.16 does not mean that these systems cannot be used for feeder installations. Rather, it means that the ampacity of the conductors must be determined based on other factors, such as the specific requirements of the load, the applicable derating factors, and the recommendations of qualified electrical engineers. The NEC provides general guidelines and requirements for conductor ampacity, and it is the responsibility of the electrical designer or installer to ensure that the conductors are properly sized and protected. In practice, when designing a 120/208 volts three-phase feeder, it is common to consult with electrical engineers and use specialized software tools to perform load calculations and determine the appropriate conductor size and ampacity. These tools take into account various factors such as the connected load, the demand factor, the voltage drop, and the ambient temperature to ensure that the feeder is properly sized and protected. It is also important to consider the coordination of overcurrent protective devices such as circuit breakers and fuses to ensure that the feeder is adequately protected against overloads and short circuits. The NEC provides specific requirements for overcurrent protection, and it is essential to follow these requirements to prevent damage to equipment and ensure the safety of personnel. In summary, National Electrical Code Section 315.6 Table 310.16 does not include ratings for 120/208 volts three-phase conductors because these systems are not commonly used for feeder installations in the United States. Applying Table 310.16 to 120/208 volts three-phase conductors would require significant derating due to the presence of the neutral conductor, which would limit the overall ampacity of the feeder.